itself. So first, before that thing, we need to go to the search icon. So after going into the search icon, we need to type Anaconda. So after typing Anaconda, I will get Anaconda Navigator option here. So if you install this thing in your laptop, it will return this thing. If it is not installed in your laptop, it won't return this thing. So after going on to this thing, you need to click on open. So here I already opened the Anaconda Navigator. So after opening that thing, it will be display the icon of this green color circle. So it is a symbol for Anaconda Navigator. So after opening this thing, you need to click on this thing. So whenever you click on this thing, so out of these platforms, so for the Python programming, these two are the preferable platforms, Spider as well as Notebook. Both are the preferable platforms. So out of for these two platforms, we are using this notebook, Jupyter Notebook. So for that purpose, here we need to click on launch option. First, we need to click on this launch option. Someone pinging me in the chat. Okay. So here we need to click on this launch option. So after clicking on this launch option, this will be launched. So you can observe that thing in the default browser. So here it is a Anaconda instance. So after this thing, so first it will be open like this. So first it will be open like this. So whereas, so here it is opening now. So previously itself I opened this thing. That's why I have this instance. So here it is opening like this. So yesterday we created one notebook on the desktop. So I want to open the created notebook only. So for that purpose, I am going to desktop. So here I'm clicking on desktop. So here yesterday I kept name as Python Basics. So here I kept name as Python Basics. So here it is a extension for Jupyter Notebook. IPYNB is the extension. So here I am clicking on this IPNYB file. So whenever you click on that thing, it will be open. So here it is the script which is created by us. Yesterday we created this thing. So after this thing, so after executing this thing, yesterday we stopped at this operators concept. So what are those operators? So here we are at operators concept. So in the Python we have 7 operators. Out of those 7 operators, yesterday I wrote only 6 operators. So the next operator is here. 7th operator is bitwise operator. 7th one is bitwise operator. So here, as you already aware of this assignment operator, and as you already aware of this arithmetic operators also. So in this arithmetic operators, I told you what is the importance of this flow division operator over this division operator. So here out of all these things, this flow division operator is a very important operator. Someone might ask you in the interview also. So what is the difference between division and flow division operators in Python 3.x expression? If anyone asks this question, difference is, so if you perform division on two integer numbers in the Python 3.x version, it will return floating point value. Whereas if you perform flow division operation on the both the things, it will return integer portion of the quotient. So that is the purpose of this flow division operator. So after this flow division operator, we have star star operator, that is called as power operator. So if you want to perform something in the power, so we need to use this power operator. Whenever you perform 10 cube, so here 10 star star 3 is nothing but 10 cube, so which returns 1000 as an output. And it is a modulo division operator which returns a reminder. Can you please keep in your mute mode so that I won't get disturbance from you guys? So after this thing, so in the shorthand, so in the assignment operators itself, we have one more category of assignment operators. Those are called as shorthand assignment operators. In this thing itself, we have one more category of operators. We have that is called as shorthand assignment operators. Shorthand assignment operators. So in the most of the cases, you might observe the shorthand assignment operators while doing programming. So here these are, so simple logic. Remember one thing. So whenever you add equals to symbols to this arithmetic operator, that will become shorthand assignment operator. So here I'm saying plus equals to, comma, minus equals to, comma, into equals to, etc. So these are called as shorthand assignment operators. So how to use this thing? You might get it out like how to use this shorthand assignment operators. So for that purpose, here I'm taking a simple example. So initially I'm defining a equals to some 10, and here I'm defining b equals to some 15. Now I want to perform operation like, so I want to perform this operation. I want to perform a equals to a plus b. I want to add a and b, and I want to store the result in a only. So if you perform this thing, and if you observe the content which is present in a, it will return 25. That means it will return sum of both the values. It will return sum of both the values. Whereas if you want to perform this thing in the simple way, so here, if you observe this example, here we use variable a two times. In order to avoid this problem, we are using shorthand assignment operators. So here, I'm saying a plus equals to b. So here, which is nothing but a equals to a plus b. So here, it is the shorthand assignment operator. So here, remember one thing, whatever the operator you are specifying at the left side, on that left side variable, you are storing the value, and we are performing the addition operation on this a and b. So if you observe the output of this thing, it will return 25 again. So if you observe what is the content present in a, it will return 25 only. Whereas again I want to perform this operation, so here I'm saying a minus equals to b. So if you perform this thing, here this operation takes place. So here, which operation takes place? A equals to whatever the value present at the left side, we are storing the output in this left side variable, which is nothing but a equals to a minus b. So here I'm performing this operation, a minus b operation, and I'm storing the result in left side variable. These are called as shorthand operators. So you will get these things in the advanced programming. So better to remember these shorthand assignment operators. So first one is the assignment operators. In this assignment operators itself, we have one more category, that is shorthand assignment operators. After this thing, we have arithmetic operators. So as you already aware of this thing, arithmetic operators always returns numeric value as an output. So after this thing, we have relational or comparison operators. So if you want to compare two conditions, you need to use this relational or comparison operators. If you want to compare conditions, we need to use relational or comparison operators. So here symbols are equals to symbol, and not equals to symbol, as well as less than, comma, greater than, comma, less than or equals to, comma, greater than or equals to. These are called as relational or comparison operators. Remember this thing, relational or comparison operators always return Boolean expression as an output. These are always returns Boolean expression as an output. So these are always returns Boolean expression as an output. So here Boolean expression is nothing but these are returns whether the expression is true or false. So someone is writing on the screen. Please don't make such kind of nonsense in between the class. So here relational or comparison operators, these are always returns Boolean expression as an output. So here I'm observing what is there in A and B. So for that purpose here I'm saying print a comma b. So here I'm taking I am observing the contents of a and b. So in the a we have 10, and in the b we have value 15. So after this thing here I'm saying a equals to b. So whenever you perform this thing, it will return output like false. It will return output like false. So it will check this condition equals to condition, and it will return the output like Boolean expression. Here I'm keeping condition like not equals to, like that. So if you want to evaluate any, sorry, here I specified one. So here we need to specify the not equals to. So here it returns true. So here if you want to evaluate or if you want to check the any condition, we need to use comparison or relational operator. So remaining operators also works in same fashion. So you're aware of all these things. That's why I'm not explaining that thing deeper. So after this thing, we have logical operators. So here logical operators are used to check multiple conditions. So in the future, if you want to check the multiple conditions, we need to use this logical operator. So if you want to check the multiple conditions, we need to use this logical operators. In the Python, logical operators are and, comma, or, comma, not, not. These are the logical operators which are present in the Python. So here, remember this thing. If you want to check the multiple conditions, we need to use this logical operator. So here I'm taking one example. So what is the content present in A and B? So in the A we have 10 and in the B we have 15. So here I want to check the two conditions, that is, so those two conditions are, first condition is I want to check this condition only, A not equals to B, and here I'm saying I want to check one more condition, that is A greater than B. So I want to check this condition. If this condition is satisfied, I want to get, so here remember this thing, logical operators also returns Boolean expression as an output. So in order to evaluate multiple conditions at a time, we need to use this logical operators. So here I'm checking this condition. So if you check this condition, it will return false as an output. Why? Because so here and is a, it works as a multiplication operator. That means whenever both the conditions are true, then only it returns true as an output. So I will explain you that thing in the script. So it is a script which I explained to previous batch students. So here you can observe this truth table. So in this truth table, initially we have A and B. Here these are the different operations. So coming to AND operation, so if both the conditions are true, then only it returns true. So here coming to this sense, 0 means false, 1 means true. So here this expression is true, whereas A greater than B is the false statement. So true into false, which is nothing but 1 into 0, that is nothing but 0 only. That's why it is returning output like false. Whereas if you perform OR operation here, it will return true. Why? Because OR operation is nothing but it works as a plus operator. So here 1 plus 0, which is nothing but 1 only. So here either any one of the condition is true, it will return true. Whereas coming to and if both the conditions are true, then only it will return output as a true. That is about this and or operation. So here I took only two conditions, whereas in the future you can take or you can compare any number of conditions. Whereas coming to this logical operators, we have one more logical operator, that is not operator. So here for this thing, here I'm applying not operator. So here not operator always returns complementary output for this thing. So if it is a true expression, it will return false as an output if you apply not to this thing. If it is a false expression, it will return, so whenever you apply not, it will return output like complementary output. So here it is returning false. Whereas if you observe this expression, it is a true expression only. Whenever you apply not to this thing, it will return false as an output. That is nothing but this logical operators. So in the Python, we have find or not or the logical operators. To evaluate multiple conditions, we need to use this operator. So remember this thing. After this thing, we have bitwise operator. So most of the guys might get confusion here itself. So most of the guys will be get confusion here for difference between bitwise as well as logical operator. So bitwise is nothing but symbols. So if you want to perform this bitwise operations, we need to take symbols. So if you want to perform AND operation, we need to take AND symbol. If you want to perform OR operation, we need to take OR symbol. If you want to perform XOR operation, we need to take XOR symbol. If you want to perform negation operation, we need to take negation symbol. And if you want to perform binary left shift or binary right shift operation, we need to use left shift and right shift operators. So these are called as bitwise operators. So remember one thing, bits are nothing but symbols. So in order to perform, so in order to take this bitwise operation, in order to apply this bitwise operators, we need to use these symbols. So here bitwise operators always used to perform operations in binary mode. These are used to perform operations in binary mode. So here, so I will explain you that thing by taking the simple example. So for that purpose, here I'm taking A equals to same 10. So here I'm taking same thing. So after that thing, here I'm defining B as a smaller value. So yeah, I will take same example. So here A is nothing but what is the binary equivalent of A? So here we have lot of built-in functions to know the binary equivalent of A and B. So here I'm not converting by using basic way. So here directly I'm applying typecasting function. So here I want to print binary of A, comma the next sorry. So in order to convert the, so as you already aware of typecasting, So in order to convert the any data in the form of any other data type, we need to use typecasting function. So here I want to convert a and b values in the form of binary. So after this thing, I want to print this output. So here after this thing, I want to print this output. What's happening here? So here we need to print binary of a comma binary of b. We need to convert a and b values in the form of binary. And the next I'm observing. So here we need to close this bracket, right? So whenever you convert this thing is 0b stands for binary representation, and it is the value corresponding to 10. So as you already aware of this thing, 10 binary equivalent number is 1010, and 15 binary equivalent number is all ones. So here I'm performing this AND operation. So here I'm performing AND operation on A and B. So here A is nothing but, so here A will be represented like 1010. So after this thing, B will be represented like all ones. So here it is a binary representation of A and B. So now I want to perform A and B operation. I want to perform this action. So as you already aware of this thing, so how to perform this binary operation? 1 and 1, which is nothing but 1 only. 0 and 1, which is nothing but 0 only. 1 and 1, which is nothing but 1 only. And 0 and 1, which is nothing but 0. So here, whenever you apply AND operation on this A and B, it will return output like 10. So here it always returns the output in the decimal only. That's why it returns output like 10. So here, if you perform this AND operation on these two things, it will return output like 10. So if you say A and B, it will return output like 10. So here it is a thing. So whereas if you want to perform OR operation between these two things, if you perform OR operation in between these two things, what it returns? So simply it performs binary OR operation and it will return output. So here 1 and 1, which is nothing, 1 or 1. So 0 or 1, 1 only, and 1 and 1 or 1, 1 only, and 0 or 1, which is nothing but 1 only. Yeah, it will return output like 15. So here it is about OR operation. Like that we have XOR operation also. So we all are belongs to ECE, we can easily understand this stuff. So here if you perform OR operation, that will return output like 15, whereas if you perform XOR operation, 1 and 1, so if both the inputs are same, it will return 0. If both the inputs are different, it will return output like 1. So here 1 and 1 both are same only, that's why it returns 0. So after this 0 or 1, 0 XOR 1 means both are different, it will return 1. Whereas 1 and 1 both are same, it will return 0. The next 0 and 1 both are different, it will return 1. So if you perform XOR operation on these two things, it will return 101, which is nothing but 5. It is the output for this thing. So I'm performing that stuff here. So here in this script itself, I'm performing that operation. Here I'm saying A or B. So whenever you perform A or B, it will return output like 15. So in place of this OR operation, here I'm performing XOR operation. If you perform XOR operation on this thing, it will return output like 5. So that is the thing I explained you here. So whereas coming to this negation operator, this is always returns one's complement of the number. Negation operator always returns one's complement of the number. Remember this thing. So the logical implementation of this one's complement is, so remember this thing. So here it is internal implementation of this negation of n. So here it will be like, we need to perform this action. So here minus number plus 1. So we are performing this operation logically on the number. So here it is the internal operation or internal design of this negation operator. So here n stands for number. So let assume, so here I'm taking one user defined number. So here I'm saying negation of 10. Whenever you apply negation on 10, what happens? So what it returns? Minus 11. Sorry. So here it is not, so it is not like this. So we need to have bracket here. We need to perform this action. So here negation of n is nothing but number plus 1, and we need to apply minus sign to this thing. So here number, so number which is nothing but 10. So here 10 plus 1, which is nothing but 11, and for this we are applying negative symbol. So whereas in this place, if you take one more example, so here I am taking negation of minus number. So if you take negative number, so here I am applying negation on this minus 19. So if you apply this thing on this thing, what it returns? Minus 19 plus 1, which is nothing but minus 18, minus of minus 18, which is nothing but plus 18. So if you perform same thing on this thing, it will return that thing as an output. So here I'm applying that thing on negative number. So here I'm applying this thing on negative number. So whenever you apply this thing on the negative number, it will return output like this thing. So here it is a internal design of this operator, this member, sorry, this negation operator. So after this thing, we have binary left shift and binary left shift and binary right shift operator. So the internal implementation of this binary left shift operator is like this. So here a less than n, which is equals to a into 2 power n. So here it is the internal implementation of this left shift operator. So like that, so we have binary left shift right shift operator also, that is a less than n, which is equals to a by 2 power n. So here remember this thing. So coming to these operators, so here it is called as binary multiplication operator. So here it is a binary multiplication operator. And next one, this one is called as binary division operator. This one is called as binary division operator. So I think you might aware of all these things. So whereas I'm revising all the basics to you. So if you are good at this thing, you can. So in the last classes of Python, I will give you the programs related to the placement perspective. So if you practice those programs, you will get perfection on the Python. So here, binary division operator. So here, remember this thing. So whenever you are performing this left shift, so let us assume. So here I'm taking one simple example. Here I'm saying 10 less than 3. Let us assume this is the example. So here before this thing, take this example only. So here I'm taking 1. So I'm shifting this digit to, so yeah, session will be finished within 1 minute. So in the